Okay, first problem, number 9 is not boxes. Woo! Okay, so that's the general function of each, state the degree, and describe the end behavior. Okay, so this one is degree 2. And it has a negative a value. Even degree things with negative a value are downward. So both arrows down. And because it's degree 2, you only need 2 directions. So 1, 2. This is your old, downward facing parabola. Okay, now end behavior. Okay, so this is the part that's usually printed on your paper. And usually you guys only need to fill in the blanks. The top line is the left arrow, which is going down. And the bottom line is the right arrow, which is also going down. Any questions about this one, number 9? So first thing I did was find the degree, which is the highest exponent when it's in standard form. I looked in the front, it has a negative a value. Even degree, negative a value means the arrows are going down. This one is degree 2, so it just had 2 directions, up, down, and negative, negative for the end behavior. You sure you're good? Okay, now move down to number 13. That's going to be one of many boxes we do today. And this one is a box with eyes in it. Four minus 8i negative 2 plus 2i. Negative 8. Okay, negative times a negative is a positive, so that's 16i, 8i, negative 16i squared. Negative 8 plus 24i. If I combine those, minus 16i squared. Okay, now if the I was any other letter than I, this problem would be done, but it's not because it's I. So do you know what to do? Anybody remember what to do? Yeah, Matthew? Beautiful. Okay, so we go negative 8 plus 24i minus 16, and then in the little I squared spot, we substitute negative 1. And then we combine. Now, back here at table 7, we were talking about too much writing. And in this problem, I don't necessarily do all of this. If it was just me doing this problem, I would go like this, and I would say the negative and the I squared cancel, and that would just give me 16. That would skip all of this. So you can sort of cheat a little bit if you can just be like, oh, the negative and the I squared cancel each other out. So that becomes positive 16. Okay, now can you guys please find the homework for tonight? It is in your packet. It is the quiz 1 review. Okay. First two, state the degree, then factor each and find all zeros. This one is degree 2. And factoring this will just be diamond and box. Does that make sense? Okay, now number 2. I want to talk about this one real quick. What degree is this one? Yes, degree 3. Perfect. Okay, now factoring this one. Do you notice how they have a GCF? You have to do GCF first on this. So I want to get that started before every single person in the class asks me how to do this. You have a cube, be like, we can't factor a cube, Mrs. Talbot. Yeah, but they all have an X in them. So you start with this. And then do diamond and box based off the things in the parentheses. Alrighty. So now you have diamond and box, diamond and box. You guys good? Yes, honey.
Like every problem, like the X thing and then like put the thing in the front.
You can if there's an X in all of them. Okay, now scroll down in your mind here to number 3 through 6. This is basically what we just did on the warm-ups, except for these, you should actually find the roots. So like this would be -1, and this would be -4 double. This would be 7, and this would be 2, and this would be 4. Do you know what I'm saying? And then sketch in the, okay, anyway, and then these two are just like the ones we just did in the warm-ups. Okay, now flip the page over. These 4 back here are all of the ones like we did on Friday where you write the equation and then solve for A. Okay, so let's do the first one here together. So y equals A. Okay, now because of mathematical etiquette, I like to look to see if one of them is 0 on this one. Do you guys see how that spot right there is 0? Can you see it? Okay, so I like to put the X. Now you don't have to have your X in the front. I just like it because it looks pretty, but it's fine. Okay, now we have a single here. So that's -4, correct? We have a single here, which is -2. And we have a double here at 5. Okay, and then they gave us this point, -5, -300, which is your X and your Y, and you're going to plug those in and solve for A. And if you missed Friday, that's basically, you're caught up now. Does it make sense? Like just plug in the X and the Y numbers and then
Yeah,
you might want to watch the video.
yeah.
Okay, anyway.
But there's no Y. Oh. Oh, shit. Oh, shoot. Sorry.
I love you so much. I missed you on Friday. I kept talking about it. It's probably in the video
Really?
about, I was like, it's not the same without Connor. I missed the liveliness. Okay, anyway, so that's this whole page. You guys understand what I want from this stuff? Yes. Okay. Now, what I would like to do is show you something. I didn't do it yet. Here, I'm doing it right now. Wow, you're watching teaching in action. Whew. Riveting. Okay. fifth of the semester will be Friday, this week Friday. No notes and no calculator. Quiz will be last 10 minutes. It only has 2 questions this time. The first one is, given the equation of a polynomial, find the degree, find the roots, find the end behavior, and sketch the graph. Yes,
Is it still 12 points?
is it still what?
12 points.
I think it's only 10 this time.
Oh.
Okay, then the equation is going to be in factored form. So it's gonna look like, if you look at your quiz review, it's gonna look like number 2 and 3. It's gonna give you an equation. You're gonna find the degree. You're gonna state the root. You're gonna state the end behavior, sketch the graph. Okay, the second question, given the graph of a polynomial, use the x-intercepts and a coordinate to solve for a and write the equation in factored form. And that is what we're just working on number 7 of the quiz review. So there's one like number 2 or 3 and one like number 7 or 8. And that's it. And the numbers are easy. I did them all myself. I think I did all 4 versions, keys for all 4 versions in like 6 minutes. So not bad. Okay, last thing I want to mention before we move on to today's lesson. Tomorrow we have the math test in this class. You guys need to bring a charged Chromebook with you for the math test. What do we use it for? Oh, all kinds of things, especially figuring out your class for next year. So do not, don't, we gotta take that one seriously. Seriously, there are kids who we've changed their schedules based on their math test, so do not.
Wait, like in the middle of the year?
No. You're picking your classes for next year this week, so.
We are.
Mhm. Have you guys not been told that yet?
Are you taking it?
Okay, anyway.
5,000.
Here is our agenda for today. We're doing 55 to, oh, we're not doing 58. It's just 55 to 57 and 63. And we're going to start using some vocab. This is pretty much the same as what we were doing before. It's just now we have some not nice numbers. And your homework is the chapter 8 quiz 1 review worksheet. And there's my joke. It says, "Dear God, no more polynomials." Yes, honey.
You ever have like vocabulary quizzes in math?
Not very often, no.
Like the polynomial and like multiple choice?
Nope.
No.
Mm-mm. The review worksheet, by the way, I'm not checking anything tomorrow because we have the math test, so that is due Thursday. Do you guys all, by the way, know that tomorrow and Wednesday are the block days this week?
Yes.
Okay. The whole point of that was because Thursday's the elective fair, which is what I was just tying into the picking of classes thing. Okay. Thank you for that. Okay, and for number 55, what I'd like you to do in your groups is to graph each one separately on the graphing calculator and write down where they cross the x-axis. So number 55, you're going to graph all 3 separately on your graphing calculator and write down where they cross the x-axis. And you guys can work together for sure. So the question is, where do they cross the x-axis?
Very good.
What?
Very good. Good for the tire.
Let's do this cycle too fast. Friction burn. We might have a surprising result when you get to the third one. Okay, when you're ready, take a look and see if you got the same things as me. First one crosses the x-axis at 0 and 4. The second one crosses the x-axis at 2, and the third one does not. Okay, so this is the start of a conversation about what happens when we get some numbers that aren't super nice. So I told you guys last week about the fundamental theorem of algebra. The fundamental theorem of algebra is very important here. It says the number of roots matches the degree. Fundamental theorem of algebra, the number of roots matches the degree. Okay, in A, that makes perfect sense. Number of roots is 2, degree is 2, move on with our life, check, happy. Okay, now, B, we talked about that one also. It only has one x-intercept, but it's a bounce. And so a bounce is a double. That's how we can reconcile the fundamental theorem of algebra in that case. Okay, so it's degree 2, and it has to have 2 roots. It does. They're both 2, which is a double. Okay, now what the heck on the last one? You just said some contradictory things. You said that the degree has to match the number of roots, but I just looked at my graphing calculator and it doesn't cross the x-axis. Okay, and that means that they're complex roots. 2 complex roots. Okay, so we're going to go back and write descriptions in here. So this is called, from now on, 2 single real roots. This is called 1 double real root, which counts as 2. And this is called 2 single complex roots. Okay, now I've brought up this new vocab word, complex. It might not be a new vocab word for all of you, but probably for some of you, you haven't heard of complex yet. What does that mean? What is complex? That's what we're going to learn in number 56. Yes, honey.
Complicated.
It is complicated, actually, unfortunately. Okay, so what we're going to do is take this one that we graphed on our graphing calculator, and we're going to find the zeros algebraically, and then you'll see what complex roots look like. Okay, so when we find roots, we want y to be 0 because that's where the x-axis is. Okay, and I want to solve for x, so I want to get x by itself, which means I'm going to minus 3 first. Okay, then I'm going to undo the squared. Undo the squared means a square root, and then maybe you could see where this is going at this moment. Do you see where it's going? Okay, so we have 2 things to work on here. First, when we square root both sides, we have to remember the plus or minus. Second, we have a negative under the square root, which means this is I root 3. Yes. Okay. And that's where this is going. Okay. Now let's talk about a couple of things. I'm gonna spend 30 seconds going deeper into this than I normally would because we have a lot of math interested people here. First, why is this not a double? Yes, there's no square. Okay, perfect. What I want you guys to know, it's really important, is the 2 plus I root 3 and the 2 minus I root 3 are very different numbers from each other. They're both single different numbers. One of them has a plus in the middle, one of them has a minus in the middle. Okay. Second, complex. Complex numbers have I'm sort of lying, kind of lying. Complex numbers in this case have 2 components. They have a real component that we write in the front and an imaginary component that we write in the back. But this is very complicated, and I normally don't talk about it in Math 3, but because of the nature of this particular class, I feel like I have to. Okay. Yeah, I know. Real number system. Real number system is everything that we've worked on so far that doesn't have an I in it, basically everything else. Okay, real numbers and imaginary numbers don't overlap each other. So real numbers are completely separate from imaginary numbers. But those over there are complex because they have a real piece and an imaginary piece. Okay, here's the part where I was sort of lying. All real numbers are also complex. If you wanted to be like a total smart aleck like Armando was last Friday, you could technically answer complex for everything. You've been working with complex numbers since you were in kindergarten. It's just that they always had a plus 0i on the end that you never knew was a thing. So 5 is 5 plus 0i. Pi is pi plus 0i. Those are all real numbers, but they're also complex. Imaginary numbers are also complex because there's a 0 in the front. 0 plus 3i. Uh-huh. Yeah, it's complicated. Okay, so normally in math 3, I just talk about real being the ones that are not imaginary and complex being the ones that have imaginaries on them. And that's a simpler conversation, but it's good enough for what we need in this class. Just so you know, there's more maths to do. Wasn't that fun? Okay, now we're going to learn another piece of vocab. Okay. First thing I want to emphasize again is that these are two separate numbers. So they're single. And they're called complex conjugates. This is not the word conjugate like in Spanish class. This is a noun, a conjugate. Conjugate in this case means that they go with each other. And they come from the plus or minus of square rooting both sides, or quadratic formulas plus or minus, either or. Okay, there's another type of root that has a conjugate. These ones don't have the I part, so they're just irrational conjugates. But the important thing in number 57 to note is that if you have one, you always have the other. So I could be a total jerk on a quiz or test. I probably won't. But I could be a total jerk and just give you one of them, and you would have to know that the other one also exists because it has to, because there has to be the plus or minus. When does this occur? Only with weird square roots and I. I know, it's bad. Okay, now moving on. Last problem, number 63, is notes, and this is the part where I said we're going to do boxes, 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 lots of boxes, 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 boxes. So many boxes. Lots of me. Boxes. So many boxes. Okay. See? Oh, yeah, 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 yeah. 3i and negative 3i. Okay, now in all four of these problems, we're just going to do factored form to standard form, assuming A is 1. You might have to do these in the future where you write it and then solve for A, but we're not going to combine both of those things today. We're just going to do the factored form to standard form piece. Okay, all of these start out the same. You take the roots and you find the factored form. So y equals x minus 3/4 x plus 5. Okay, now I don't know about you, but I really don't want to do a box with 3/4 in it. Do you remember the trick I taught you for when it's a fraction?
Um, okay.
Perfect. You move the denominator to the x. Now, this is a much friendlier box to me. And this is a 2x2 size. Okay, any questions about A? Factored form, standard form. We good with A? You sure? Okay, now let's do B. Y equals x minus 3i, x plus 3i. You want to switch the signs of these just like when they're regular numbers. So switch the sign, switch the sign. 2x2. Okay, so just get the box part down first, this part. And what I want you to notice is that this box and this box canceled. When you have imaginary conjugates, these two boxes will always cancel. As a matter of fact, you don't even need to write them in. Let me say that again. When you have imaginary conjugates, these two boxes will always cancel. You don't even have to write them in. You might forget and just write them in and be like, oh yeah, Mrs. Talbot said those two were going to cancel. And they do. Okay, but also this guy, what is negative 9i squared? So the negative and the I squared cancel each other out and it becomes positive 9. So the negative and the I squared cancel and it becomes positive 9. Okay, so the standard form is y equals x squared plus 9.
What did you do? Get rid of the square. No, 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 at the end.
We're just writing the equations. We're not solving anything.
Oh,
You just gotta like resist the urge and just leave it.
mhm.
Okay, now these are more challenging to do. The first step is the most important. And I want to scroll back up here. What did I do to get the standard or the factored forms of these? Reverse the sign. Beautiful. Okay. If you know that, then you're good. Y equals. Okay. X. Now, when I reverse the sign, I need to reverse all the signs is what I mean. So minus 5 minus 2i. That's this one. X minus 5 plus 2i. That's this one. So X, switch sign, switch sign. X, switch sign, switch sign. Okay, now what size box is this? You're not going to like the answer. It's a 3 by 3. The good news is that if you're a person who detects a pattern, you don't need to fill out the whole box. Some stuff will cancel because these are imaginary, I should say, complex conjugates. X minus 5 minus 2i minus 5 plus 2i. Okay, so let's figure out which boxes we need. So x squared minus 5x negative 2ix minus 5x 25 positive 10i positive 2ix negative 10i negative 4i squared. Okay, now pattern detection. These two boxes will always cancel. You don't even really need to write anything in them if you don't want to. Some students just shade them. These two boxes will always cancel. And this box will always simplify. What is negative 4i squared? 4. Like positive 4i squared? Then that would become negative 4. Excellent question. Okay, so we have y equals, I'm going to use my red pen just to circle some things I'm going to combine. So I'm going to combine these two. And I'm going to combine those two whole numbers. So I have x squared minus 10x plus 29. Oh, that looks familiar. Does it look familiar? Does anybody know what I'm talking about? Nope. It was from number 49 from the homework. 49, I think it was. All right, last problem of the day. Y equals x. Switch sign, switch sign. X. Switch sign, switch sign. 3 by 3. I want to note real quick, especially on the video, that for the quiz, it specifically says leave in factored form. You don't have to multiply it out for the quiz, just factored form. X plus 3 minus root 2, x plus 3 plus root 2. X squared, 3x, negative root 2x, 3x, 9, negative 3 root 2, root 2x, positive 3 root 2. Okay, now we got to be really careful here. A negative times a positive is a negative root 4, which is negative 2. Okay, did my theory about which boxes to skip hold true with irrationals? Yeah, so don't really need to do this box and this box. I did it because it's notes, but you don't have to. Didn't really have to do that box and that box. I did it because it's notes, but you don't really have to. Combine these two. Combine these two.